I completely for reminding me. See, sometimes I forget to record. But good thing is that the next class meeting, I usually try to go over same ideas. So you basically see the lectures twice, the ideas that appear. So I guess that hopefully fixes it. So what we did last time, we found the derivative, we made it equal to 0, and that gave us ability to find the so-called minimum point on the graph, such a special point where the tangent line that touches the parabola has 0 slope. Turns out those points of minimum and maximum. Absolutely, and that's what I recommended students to do. So you can do exactly the same problems that I done in class and submit them as your homework. So for homework, I just want you to practice. I'm not telling you exactly which exercise to do. If you like, you can do whatever problem you want. And if you need my help, just ask. I will do it for you, will help you. And I recommend it just do same problems that done in class. I think it'd be easier on you because you will be able to just follow through the steps of solution. And turns out it's a good idea. It's always the way to learn mathematics. Just get a pen, pencil, and basically copy a solution that somebody produced, and of course, give it a little thought or try to do it yourself and then see how I solved it, which is even better. And you can do it only once, or if you do it more than once, that's fine with me. I told that from each section, couple of problems will be good enough. So you don't have to do everything that I done in class, because I do quite a few exercises, but like 2 problems should be enough because they basically repeat exactly the same thing. So we started section 3.1 last time, and today I want to continue with the section 3.2, and that's, I guess, the plan. So I just turned to the next section and I see pretty much same problems. So I want to do another one, like exercise number 6. So I'll do one problem and then I guess it'll be enough, because it will actually repeat the same plan as for the previous exercise. And then we'll talk a little bit more about the midterm. I know it's exciting time of semester. And the last thing I want you is panic. I don't want you to panic at all, because there is nothing to panic about. You're going to have plenty of time. You're going to have pretty much the same problems that I solve. And I will also be logged in for just in case on that Monday next week. So if you have any questions, you can always ask so I can clarify. Of course, I should not solve the problem for you, but I will solve very, very similar exercises on Wednesday. So here's the function, which is 4th degree function. And 4th degree function turns out usually has a shape of a parabola. There might be a wiggle in between of this central area, but we'll discuss that. So first step is taking derivative. So I'm going to get a 4 multiplied by x cubed, right? So I just put 4 on the ground. With the next piece, I put 3 on the ground. So times -4 is -12 with x squared. And finally, 10, right? X disappeared. So that's our first step for all of these exercises. And the next step is to set this equal to 0 and try to solve it. So looks like this exercise will be difficult to solve. And indeed, this exercise is actually not as nice because for some reason they don't even ask us to graph. So they talk about so-called inflection points. So let me continue with this. So I can't really solve it at this stage because it's a cubic equation. We never solved those cubic equations by any methods but tried to factor, but looks like I can't really factor it. There's no x term, right? So I guess I'm not gonna do that. But what I'm gonna do is take a second derivative. That's what they want me to do, turns out here. I say I can take another derivative. Yes, you can take derivative of derivative and again and again. And after I take second derivative, so it'll be 12 multiplied by x squared, and minus 2 times 12 is 24 multiplied by x. I will also set it equal to 0. And this equation I can solve. I can, first of all, make it look simpler, divide by 12, because the smaller numbers are, the better. So we're going to have x squared minus 2x and then equal to 0. So I can factor out letter x. So we have x minus 2 in the parentheses. And this tells me that I have two so-called zeros of second derivative, which is going to be number 2 and 0 itself. What does this mean? Well, what it means is that we have special points of so-called inflection. In other words, the function here in between of those points looks like parabola that opens downwards, and then starting from that point and going further looks like parabola that opens upwards. So it changes how the function opens, either upwards or after that point looks like it opens downwards. So you can imagine yourself approximation with parabola. You say with parabola? Well, yes, for the first derivative, turns out we're using approximation with a line, and for the second derivative with function like x squared or parabola, which is interesting to think about. What I can do, since I cannot find those points, is give you one very, I think, important hint. I'll introduce you with a free graphing calculator. All you need is to start typing graphing calculator, and the one will appear for you. So you can use it for free. And this is my favorite Desmos choice number 1 for the calculator. That will enable me to graph this function. And what I need is to get a keyboard to be able to enter it, and it's here in the lower left corner. So I'm gonna give you this link so you can just click on it and maybe bookmark or save it someplace. I think that'd be definitely helpful, because we're gonna see lots of exercises that will tell graph, and this tool is very useful. So once I hit this keyboard, then you can see that numbers appeared. So all I need is just to enter this function, such as x, and then raise to the power. So the power is here. So what I do is I just click on that power and 4 next to it. And you can see 4th degree parabola that appeared, but that's not what we need. We need to do more. So I continue, minus 4, another x to the power, and the power will be 3. So far, I don't really care what it shows. I just need to finish my entire entry. So again, I put cursor on the ground and go with a plus 10x, 10 next to x, and then finally minus 9. So here's the graph of that function that we have actually in the exercise. So let me clean a little bit of this mess here. So what I can do with this graph is I can zoom it in and out so I can better see the actual function. So if I put it a minus, so I can see the graph, how it looks like. And now what happens is at the point 0, so what we just found, that at point 0 and at point with coordinate looks like 2, right? That's what we had. 2 is here. I guess it's not really scale. It's like 10 from 0 to 10 here. So it's like each square is a little bit. Actually, it's 2, right? So it's 2. So it's here. And those are points we found. So what's so special about these 2 points is that if you look at the part in between of 0 and 2, this looks like a parabola that opens down, right? Actually, 2 is here. So parabola that opens down. And then starting at the point where we have that little tool, the parabola changes its behavior and starts to go like upward, opening parabola. And same here, also like upward. So I guess I messed up this nice picture a little bit. But anyways, so I guess my goal today was to introduce you with this beautiful free tool, so-called graphing calculator, which actually costs about $100 plus. If you ever had one with a big screen like Texas Instruments or Casio, they have very good graphing calculators. But I found absolutely free one online for you to utilize. And the reason I gave it to you is not because I want you to just graph using this calculator. I know some students know graphing calculators. I just want everyone in class to be in the equal position. So if someone uses graphing calculator and someone doesn't, I don't have control over it. That's why I decided to give it to everyone. So let's be fair, right? So also, we'll see that besides using graphing calculator, we're going to also need a little extra here. So we're going to need to find first derivative, second derivative, but that's exactly what they're designed for. And if we were able to find solutions for the original, for the first equation, it was the first derivative that I couldn't solve, then we would have seen these points of minimum and the maximum, and the fact that it resembles parabola because both ends go upwards, so it's similar to the graph of x to the power of 4. I guess that's the key idea in this exercise. I was just thinking maybe I'll do another problem for you because I couldn't graph this one without a calculator, so maybe I can try another because I don't plan to give you a quiz today anyways. Maybe I'll graph one more because honestly I really love graphing and I think it's exciting part of the course, so you get to find derivatives and actually use them, and that's the part that definitely makes lots of people happy. But I should move on and select the problem in the next groups of exercises because they don't here expect us to graph, and that's why functions that appear here are not that nice, they're not that straightforward to work with. So I'm gonna take one on the next page, and I think this is gonna be something doable. So let me try number 28 exercise, for example. I'm selecting today only these polynomial so-called functions without any denominator stuff, because this is what we're actually learning how to graph in this class. Because yes, there are various other tricky functions, but they will take you a while to do, and that's why I would say you don't have to bother with them. In fact, if you ever need to graph, well, I just shown you a graphing calculator, and you can definitely take advantage of that. So, first derivative and a second derivative. So we already know we need to find two of them. So first derivative is 4x cubed and minus 2 times 2, another 4 with x, that I will make equal to 0. And then second derivative right away I can also find, so I can also make it equal to 0. This will be 12x squared and minus 4. So set them equal to 0, factor, and see what comes out for those special points. So it looks like here I can take out 4x as a common factor and have x squared minus 1 in the parentheses. So either 4x is 0 or x squared minus 1 is 0. And 4x equals to 0 means that x is 0. And if I have x squared minus 1 is 0, means x squared is equal to 1. And when I extract the square root, there'll be either plus 1 or minus 1. So I already have 3 points that I care about: 1, -1, and 0. For the second piece, I can do analogous solutions. So I can write 12x squared is equal to 4. So divide both sides by 12, and we're going to get 1/3, right? And then it looks like I'm going to have to square root that 1/3. So x will be plus minus square root from 1/3. So the point of story, I found another 2 special points. And this gets a little bit lengthy, because now we need to technically deal with 5 points. And I guess, well, that's good type of exercise to try once, because it's a little bit tedious, but it's not really that bad, because those with denominators usually are much worse. So let me now try to graph this function using those special points. And since I found them, such as 0, 1, -1, and then also 1/3, right? Square root. Well, I guess those I'm not going to bother with. I think it should be enough with just these 3 to already get an idea how the function looks like. So here's +3, and this is going to be just a 3, right? Plugging in 0 is always my favorite. 1, so put now 1 instead of x. So it looks like we have 1 minus 2 is -1, and 3 will be a, so 1 minus 2 minus 1 plus 3 is 2. And finally, if I use -1 instead of x. So notice with whole numbers is not that bad, but if I start to use 1/3, it will be, well, I will need to use a calculator, because without it, it'd be a big mess. Plus is a square root. So it's 1, and then -2, and +3, which is also equal to 2. How about that? So I like this. We're going to be now trying to plot those points on the plane of coordinates. So what are the points? Well, first one, when x is 0, y is 3. So put point 3 someplace here. Second point, when x is 1, it's not equal. when x is 1, y is 2, so that's a little bit lower. So place here. And then analogous point is the last one, right? It's a -1, y is also 2. So that'd be someplace here. And the way I connect this, analogous to the previous example when we had a parabola with both ends going up, because that's a even function. For all even functions, both ends go upwards. Now, what else can I say here? Well, this number's square root 3 in denominator will be less than 1. So somewhere in between here and here will be my inflection points, which means that my parabola starts going upwards from that inflection, and the same from the other inflection point. And in between of them, it'll be like a parabola that's going downwards that connects somehow. So I guess there is no need to actually find exact values of those inflection points, whatever they will be. Maybe like 2.178 or whatever. So who cares? It's a little bit up higher, and that's what we actually produced on the graph. And of course, you can check this with a graphing calculator tool that I just introduced you with, that Desmos graphing calculator. Again, it's in the chat, so you can always utilize it. And it's helpful to make sure that you indeed done the problem correctly. So this continues graphing story. And as I said, we're going to have the midterm. Now I want to tell you what be for the homework. I guess we'll go up to day, so up to section 3.2. So let me exactly tell you which sections will be for the homework. And I guess all you need is just watching those lectures, and I will, by next class meeting, produce those recordings on the YouTube, so they will conveniently stay at one place. I think that will be nicer, right? Because right now you can pull out those recordings from your student email. I was sending it to everyone, but I think on YouTube will be nicer. So from chapter 1, let's see what we actually didn't do there. I think we did 1, 5, 1, 6, and then we also looked at 1, 3 through 1, 1, 1 through 1, 3. So let me list it. 1.1 through 1.3, which actually means 1, 1, 1, 2, and 1, 3. But again, whatever's in the lectures, because I was selective in those sections. So that's 1, 5, and 1, 6, but just for you to see what sections we did. Now we found derivatives, so we actually talked, I would say 2, 2, 2, 3, and 2, 4 here. So from 2.2 through 2.4, because 2.1 was introductory section, and I guess if you know how to do 2.2, that's good enough in here. So, but again, in section in the lecture related to this story, I did some exercises from 2.1, because they're the same thing as we see in next sections. And now 3.1 and 3.2, two other sections. It's actually the last thing that one should worry about. And maybe next time I'll do more of it. We'll see how it works. So later today, I will email you this recording along with a practice midterm exercise, so you will see what exactly will be on the midterm, and also how to do it, because we'll do it together on Wednesday. So that's the plan for this week, and I'll let you, you're welcome. So I'll let you log out and start to put your homework together. find what sections you did, what sections you didn't, and maybe finish up with some of the homework, because I make it due on Monday. Well, if you're not going to make it by Monday, you can send it to me on Tuesday. That's fine. I accept late work for full credit. It's not a big deal. But I guess for you, it'd be more convenient to do homework before the midterm, right? Yes, those are homework sections. I try to put HW like a homework here. It's hard to see, I understand. So maybe I can move this a little bit. This text, it doesn't move, it's a Acrobat. But yes, that's a homework. I say, what if I don't do one? Well, it's okay. I'm not really picking on what you did, how you did those problems, as long as you practice. That's the key part. That's what I really care about. So you do something outside of class. This way you get better result on the midterm. So if anything else, please let me know. If you don't have any questions so far, you can always email me your question and I will reply by email, or if it's such a good question, I will discuss it next time with a whole class, because sometimes they're very, very important questions that people ask me that I might forget to cover. So don't hesitate. Just tell me whatever is on your mind, and we'll do my best to reply and to help you with it. Or maybe this type of exercise is not going to be even on the exam, so I'll let you know. So again, no quiz today, and Wednesday next time we're going to discuss midterm in very detail. I will send you copy a PDF file so you will be able to easily open it. Just click later today, just check your emails, and that's pretty much all for today. So I guess I'm gonna end it for now, since I don't see many questions coming. So we'll talk about it more. I'm sure you will like it.